Next step I'm going to do, I'm going to go the limit of f of a plus delta x minus f of a as delta x approaches 0. Now I'm going to multiply this times delta x over delta x. That's still 1. So I'm using the concept of equivalent fractions. So I'm writing this in another equivalent form, because remember, I can also write this as a fraction by simply putting it over 1. So you see how effective and useful those concepts are? So those concepts that you were taught and drilled into from grammar school, we're applying it here. We're going to use the concept of equivalent fraction. Multiplying a fraction by 1 does not change that. Multiplying it by 1 in a different form does not change that fraction. So I'm using the concept of equivalent fractions here. Multiplying top and bottom by the same number does not change that fraction. Are you ready now? So now the next step is I'm going to simply multiply this times 1. I'm going to leave that delta x there. So now I'm also going to enclose this in brackets. And we're going to use the theorems of limits that you should have picked up earlier. So now rewriting that, now I have the limit as delta x approaches 0 of, in brackets, I have f of a plus delta x minus f of a divided by delta x times delta x. Please copy this. Everybody here, please copy this down. Are there any questions as to what I did? Again, I must stress you cannot forget your concepts. This is simply using the concept of equivalent fractions. I'm changing this fraction to another equivalent form. So then I change the form again. This is still the same thing. I'm just multiplying this in the form of 1 by writing delta x over delta x. I'm utilizing the concept of equivalent fractions. Do you see that? Very good. Please copy this. Juan, Maria, please copy this. Please copy this. I'll give you about a minute. I'll pause the video, give you an opportunity to pause this before I go on. I'm going to take my time because I need to make sure that you see this clearly as I have. Okay, this time, please copy the work. I will pause the video. I will return. Okay, ladies and gentlemen. Peter, Juan, are we all set and ready to go? Julio? Okay, excellent. Let's see. Patricia, Linda? Good? Okay. Now, our next step, we're going to use the theorems of limits. We're going to basically distribute this limit through. Let's go to the next line. So now I'm going to go the limit as delta x approaches 0 of f of a plus delta x minus f of a divided by delta x times the limit of delta x as delta x approaches 0. Do you see that? Am I going at a good pace, everybody? All right, let me move out of your way. Before I discuss this, please copy this. So let me give you an opportunity to copy that, please. Okay, at this point, I am going to pause the video to give you an opportunity to copy this portion. All right, ladies and gentlemen, so now we have applied the theorems of limits by somewhat distributing this expression. Now, let's examine each part here. What is this part equal to? Do you recognize that? The limit of f of a plus delta x minus f of a divided by delta x as delta x approaches 0. Do you recognize that? Let's see. Peter, do you recognize this expression here? Do you recognize that limit? What is that limit? Yes, it is. Excellent. Very good. I'm proud of you. Very good. Yes. All of you see it now. Very good. What about you? What is this expression? The limit of f of a plus delta x minus f of a divided by delta x. What is that expression? I'm listening. Very good. Yes. Exactly. Very, very good. Yes. This expression is the derivative f prime of a times. Okay. Well, now, I have this piece here. I have the limit of delta x as delta x approaches 0. What is that equal to? As delta x approaches 0, what is this going to approach? Let's see. Maurice. Oh, okay, I'm sorry. Yes, excellent. Yes, exactly. Does everyone agree? Maurice said that this is going to approach 0. Do you agree with that? You agree with this assessment? Very good. So, now this is times 0. Well, anything times 0 is 0. What have we just shown? What have we just shown? Felicia? Yes, we have. Yes. Very good analysis. What have we just shown? I'll let you know what Felicia said. I just need to hear from you. What have we just shown here? What? Yes. We've just shown that if f is differentiable at a, it is continuous by a, at a, because we got 0 here. Why? Well, remember, we started out with delta f, and we rewrote delta f. So now, we've just shown that this is equal to, from the definition of continuity, the limit of delta f as delta x approaches 0. In order for a function to be continuous at a point, this must equal to 0. And this was just another way we rewrote this using algebra to rewrite delta f in a different form using equivalent fractions. So we did not change it. We just rewrote it in a different form. So we have just shown directly from the definition of continuity, we used the definition of continuity to prove that if a function is differentiable at a point, then it is continuous at a point, because we have just shown that the limit of delta f, let me move this way, that the limit of delta f as delta x approaches 0 is indeed equal to 0. And that, ladies and gentlemen, is the definition of continuity. So we used the definition of continuity to prove that if this function is differentiable at that point, by the definition of continuity, it is equal to 0. We just showed that the limit, again, of delta f as delta x approaches 0 is equal to 0. That is what we have just shown. Are there any questions? Let me wait, give you guys time to think it over, look this over, let me give you time to think. I'll take any questions. I need you to see this, because when I was in your seats in high school, it really didn't become vividly clear until later on in college when I had to actually start teaching. When I was working with other students, tutoring as well while I was taking advanced courses, and it really finally clicked in. So I want you to vividly see how we used the definition of continuity to prove that when a function is differentiable at a point, that it is continuous there by the definition of continuity. We used the definition of continuity to prove that. Questions? Do you have any questions? If so, please send it to me by way of email, and I would gladly respond to you. Let me move out of your way, give you an opportunity, and again, I must stress to you, as my professor, Professor Keys, and also Professor Milojevic, who I have to get credit to, and Professor Blackmore. Both of these professors are at NJIT in New Jersey, and Professor Keys teaches at Rutgers Newark. These three individuals were significant in my mathematical life and training. I have to give them the respect and acknowledgement that's due to them. And as Professor Keys said to me, I'm going to say to you again, write this down. Put it on paper. Get your favorite cocoa or juice. Close your door. Get away from any other distractions and just smell the cocoa. Enjoy it. Relax. Give yourself time to think it through, because when you're under stress and pressure, it can't come in. So I'm asking you to do the same thing, because that was really beneficial to me when Professor Keys told me that. So I'm going to share the same thing with you. Get your favorite cocoa or tea or juice. Roll up in a room and really look at this and think about what I said and how we used the definition of continuity to prove this. So in the meantime, let me move out of your way, give you time to copy that, and we'll close out. All right, ladies and gentlemen, you should have this copy down. If not, again, you know you can pause the video and copy the information. Thank you for joining me. Please, I really need to hear from you. Let me know if my presentation and instruction was it clear. Did I move too fast? Did I give you enough time to think? Did I give you wait time to think about what needed to be done next, to give you time to see if you could see what must be done? Did I correctly lead you by the hand, as Socrates would do? He would not come right out and give you the answer. He would try to show you where the answer is and act as a guide. Did I do a good job in guiding you to understanding the solution and why? I need to hear from you. Please let me know if I did a good job for you and if I cleared up and made this clearer for you to understand. Thank you for joining me, and I sincerely do wish you much success in your mathematical career and endeavors. Thank you for joining me.